name is Sarah Villeneuve. I'm a program lead for the Fairness, Accountability, Safety, and Transparency team at the Partnership on AI, and I'm here with my colleague, Mckane Andrus, Senior Research Associate. We are presenting our paper, Demographic-Reliant Algorithmic Fairness, Characterizing the Risks of Demographic Data Collection in the Pursuit of Fairness. As the fact community is well aware, algorithmic decision-making inscribes certain risks around systemic, albeit unintentional, discrimination or unfairness. A common requirement of techniques to resolve algorithmic unfairness is demographic data. However, many organizations choose not to collect this data due to a range of organizational and legal barriers and concerns. This leaves AI practitioners at a loss for how to identify and assess discrimination in their systems. Simply ignoring or not collecting data about group membership has been clearly and repeatedly shown to fall short of any standard of fairness, and instead is likely to ensure that systems remain biased in hidden and poorly understood ways. That being said, data on group membership in many domains remains either inaccessible or unreliably collectible, making many proposed mechanisms of identifying and mitigating algorithmic unfairness infeasible. In our prior work, we explored the challenges practitioners and institutions face when attempting to collect different types of demographic data for the purposes of making fairness assessments and interventions. When speaking with practitioners, we often encountered questions around how demographic data should be collected responsibly to support fairness interventions. And what we realized was before answering this question, we needed to first consider the more normative question of if or when demographic data should be collected. To understand when, or even if this data should be collected, we needed a clearer picture of what risks may emerge when collecting and using demographic data for algorithmic fairness purposes. In this paper, we argue that by confronting these questions before and during the collection of demographic data, algorithmic fairness methods are more likely to actually mitigate harmful treatment disparities of marginalized groups without reinforcing systems of oppression. Before we dive deeper into the content of this work, we want to define what we mean by demographic data. We use this term to refer to categorizations about individuals based on observed or self-identifiable characteristics such as skin tone, hair length, and vocal range, to name a few. These characteristics are used to inform demographic categories, which attempt to collapse complex sociopolitical concepts into categorical variables. This project of categorization can oftentimes be misaligned with the needs, desires, and experiences of the people being categorized, meaning that it's entirely possible for fairness efforts to be misaligned from the start. In the next sections, we delve into what these misalignments might look like and the types of risks they entail.
So the risk we discuss in our paper fall into two categories: the risk to individuals and the risk to communities. Risk to individuals include the unique privacy risk associated with the sharing of sensitive attributes likely to be the target of fairness analyses, the possible harm stemming from miscategorizing and misrepresenting individuals in the data collection process, and the use of sensitive data beyond data subjects' expectations. The risk to communities include the expansion of surveillance infrastructure in the name of fairness, misrepresenting and mischaracterizing what it means to be part of a demographic group or to hold a certain identity, and data subjects ceding the ability to define for themselves what constitutes biased or unfair treatment. First, we'll discuss the risk to individuals. Perhaps most obviously, collecting data on individuals' group membership carries a range of risk around impingements on individuals' privacy. Most directly, many categorizations that might be salient axes of algorithmic discrimination are also categorizations that governments and policing institutions are likely to target discriminatory or oppressive practices towards. Attributes such as documentation status, political affiliation, and sexuality cannot be shared without entailing some type of risk for the individual. Similarly, collecting demographic information also carries the risk of exposing data subjects to bigotry and direct discrimination in the case of unvetted data sharing and data leaks. And furthermore, depending on how data is collected and how much agency data subjects retain over it, there is also risk of reducing an individual's autonomy around how they present themselves. The collection and use of demographic data in algorithmic decision-making systems also carries the risk of individual miscategorization and identity misrepresentation. This risk can arise when these systems fail to accurately represent an individual's identity. More specifically, individual miscategorization can occur when an individual is misclassified, despite there being a representative category that they could have been classified under. For example, if an individual is miscategorized as female rather than male in a binary dataset. Identity misrepresentation, on the other hand, can occur when categories used do not adequately represent the individual as they self-identify. For example, if an individual who identifies as non-binary is classified as female because the category does not exist for them in a binary dataset. Miscategorization and identity misrepresentation may not only lead to social and political discrimination, but also psychological and emotional harms via feelings of invalidation and rejection. The final individual risk we consider is data misuse. Corporations collecting and using individuals' demographic data to train and deploy algorithmic decision-making systems are facing increased pressure from both the public and regulatory bodies for transparency on how such data is collected and used. So data misuse can refer to either the use of data for a purpose other than that for which it is collected or consent was obtained, or instances where data is shared with third parties or packaged and sold to other organizations. So where individuals might be willing to share their data to improve the experience for other people like them and to increase visibility of the types of challenges they face, data collected for these purposes must be strongly protected from any other type of sharing or use to maintain trust and consent.
Moving on now to the risks to communities. The assumption that more data will result in fair algorithmic systems neglects to consider the risk of expanded surveillance and questions around who benefits from increased data collection. Nowadays, data collected from communities are rarely accessible or utilized by those communities themselves, particularly those who are already marginalized and vulnerable. Instead, data is used by private actors or siphoned off to external institutions to monitor and manage groups. Scholars of surveillance and privacy have shown time and time again that the most disenfranchised and at-risk communities are routinely made hypervisible by being subjected to invasive, cumbersome, and experimental data collection methods, often under the rationale of improving services and resource allocation. Increased visibility and awareness of being under surveillance is likely to have a chilling effect on already disenfranchised groups and society at large. Next is the risk of misrepresentation and reinforcing oppressive or overly prescriptive categories. At a high level, these risks center around essentializing or naturalizing schemas of categorizing without flexibility over space and time, and misrepresenting reality by treating demographic categories as isolated variables instead of structural, institutional, and relational phenomenon. Misrepresentation occurs when entire groups are forced into boxes that do not align with or represent their identity and lived experience. In these cases, systems often embed very narrow standards for what it means to be part of a group, defining elements of identity in a way that does not necessarily align with the experience of that categorized group. Even in cases where groups feel adequately represented by a categorization schema, there is a risk of reinforcing and naturalizing the distinctions between groups, especially in cases where demographic variables are uncritically adopted as an axis for differential analysis. Varying outcomes across groups can be incorrectly attributed to these variables. The final risk we consider in this paper is the risk of private control over scoping and defining what constitutes bias, discrimination, and unfairness. Organizations that collect demographic data have a wide range of techniques and approaches they can possibly employ when it comes to both collecting data and interpreting that data. What technique they choose to collect data and how they decide to interpret this data will depend on the goals of the fairness intervention. When those collecting data have blind spots around what impacts decision-making and individuals' life experiences, have various forms of discrimination and inequality can run the risk of being misread as inherent qualities of groups or cultural differences between them. As such, when an organization is asking already marginalized groups to share information for the purpose of assessing unfairness, it is important that unfairness is defined in concert with the groups in question.
So there have been a range of proposals on how organizations can feasibly collect, manage, and employ demographic data responsibly. In our paper, we discussed two approaches that have the potential to address some of the risks that we've outlined here. The first path forward consists of a range of approaches that aim to prevent organizations from ever directly learning user-sensitive attributes. Most of these approaches prioritize anonymizing data sets that include demographics by enforcing standards such as k-anonymity, p-sensitivity, and/or differential privacy. In many cases, these mechanisms are used to enable secure multi-party computation as a means of protecting sensitive attribute data from the decision-making institution and outside attackers. These approaches ensure individual sensitive attribute data remains encrypted at each stage of use, while still enabling basic computations to generate aggregate level takeaways. These methods can protect against the direct discrimination of individuals, as well as some types of data misuse and surveillance, but they often neglect the range of individual harms that extend from the relational aspects of data and the community level risk of demographic data collection. Secure computation techniques are generally concerned with an identifiability notion of privacy, which centers the question of if data is attributable to an individual. What they miss is more of a control-focused understanding of privacy, which speaks to the ability of individuals to influence what data about them exist, how it gets used, and towards what ends. An alternative path forward that we discuss as a possible mechanism for mitigating the risk that the previous approaches do not address is the participatory governance of sensitive data. Participatory data governance models that involve data subjects more directly in determining what data is collected and towards what ends, such as data cooperatives and data trust, can help mitigate most of the previously described risk to individuals and communities. Data cooperatives specifically are characterized by a decentralized data governance approach, where data subjects voluntarily pool their data together for mutual benefits. These types of data governance models reduce the risk of both individual and group misrepresentation by including the subjects in decisions regarding what types of data are collected and how these are categorized, enabling previously disenfranchised groups to directly define their group identity and exercise control over the applications of their community's data. These methods also mitigate the risk of data misuse or use beyond informed consent and provide data subjects the ability to exercise influence over how fairness is defined, what types of fairness assessments should be conducted, and what data should be used to conduct those assessments in a given context. All of this being said, unless the builders of algorithmic decision-making systems are compelled to approach demographic data collection and use responsibly, or even engage with anti-discrimination in the first place, neither of these approaches are likely to be adopted. Thank you for listening to our presentation, and please check out our paper for a deeper discussion of these risks and paths forward. Thanks so much.